Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. So today's problem is kind of similar to the previous one, but a little bit more different. So we have point A, we have point B, and we have body that moves with the speed v1, and it moves for the time t0, and then after t0 this second body moves with v2, and the distance of course is d, and we asked when they will meet. As always, several ways to solve it, and let's start here with the simplest possible way, with kind of direct analysis, geometry. So the first body moves for the period t0, and it covers this distance from this point to this point, and this distance, because it's moving with v1, and for the time t0 this distance is this. Okay, then after that we have two bodies, v1, and the second body is moving with v2, and this remaining distance of course is d minus this distance minus this, d minus v1 t0. And let's move for a change, let's go from that moment into the system coordinate related to the first body. And the second body is moving away, v2, but we're moving v1, so that means we're approaching this body with the speed v1 minus v2. And we have to cover this distance. Okay, so in this system of coordinates, this remaining time would be this distance, d minus v1 t0 divided over v1 minus vt. And that basically solves the problem, except they are asking us about the time not from t, this time is from that moment to the moment of interception. So from the beginning we have to add this t0. So it would be t total, it would be t0 plus this t would be a d minus v1 t0 divided v1 minus v2. Okay, so let's put it to the common denominator, and let's remove this t0, and let's continue writing here. We will have t equals, common denominator would be this, v1 minus vt. We have to multiply it 0, t0 multiplied by this v1 minus vt, and we have not to forget add d and this minus v1 t0. So t equals v1 minus v2, and I open the brackets, would be t0 v1 minus t0 v2 plus d and minus v1 t0. This and this is the same, and so this would be the result. T equals v1 minus v2, and the top would be d minus t0 vt. And this is the result. I will put it here because I will come back to this with different angles. T equals v1 minus v2 and d minus t0 v2. And that's basically it. Only we have to put the numbers. And if we will put the numbers, we have v1 equal 100, v2 equal 50, distance equal 200, and t0 equals 1 hour. So it's very easy to put here. We will have t equal, and put here 200. We have to put here t0 equal 1. We put here v2 equal 50. And at the bottom would be 100 minus 50 would be 50. So it would be 150 divided over 50. It would be 3 hours. And of course that makes sense because we're moving here for 1 hour 100 kilometers. So this distance becomes 100 kilometers. The total distance is 200. So we have to cover 100 kilometers between our cars, and this will take us 2 hours, and so in total it will take us 3 hours. 1 hour to travel this distance, then 2 hours until we reach the intersection. The cars will be at the same point, and so total time would be 3 hours. And so at the first glance that concludes this problem, except there is way more to this. And I will discuss this in the next sections discussing the same problem. So you may click on the following problem in the playlist, and the one after that I will record this video shortly. Thank you. And as always, don't forget to click like, don't forget to click subscribe, don't forget to click the bell. This way you will be notified when I upload the next video. And there are a lot of problems that I am planning to upload shortly. Thank you very much for watching.